A 100-pound engine hangs from 2 wires attached to the ceiling. If the left-hand wire makes a 50-degree angle with the ceiling and the right-hand cable makes a 32-degree angle with the ceiling, find the tension in both of the wires. All right, let's draw a picture. So here's our ceiling, and let's go ahead and put, we've got a 100-pound engine, and so we've got one vector that is pulling up this way, and we've got it's at a 50-degree angle, and we've got another one this way, and it's at a 32-degree angle, and we have this engine that would be pulling down because of gravity, so it's 100 pounds down this way. So that's a picture with the information, and we're going to find the tension in both wires. We'll call these, so the magnitude of this one will be T1, and the magnitude of this one over here will be we'll call that one T2, or the things that we're supposed to find. All right, so let's see what information we have and what we would want to do. And because this is in equilibrium, meaning it's balanced, it's not moving, it's hanging there, the forces pulling up are equaling the force pulling down. So the sum of the forces equals 0 when something's in equilibrium, not being moved, you know, at all. It's just there. So we could put the 2 equal to the other one, but in the opposite direction, or we could add sum all 3 of them, and those need to equal 0. So let's see if we can express the different vectors. So let's do T1 first. And as we look at T1, I'm going to actually put a coordinate system in here so it will make it maybe a little easier to work with. We'll put the origin right there. And so I'm going to draw this one down here. I'm going to get this T1 maybe out of the middle of this triangle so we can see what we're doing. And so I want to break this force up essentially into its X and its Y components. And I'm going to do the same thing over here in a minute for T2. So we could break it up into its X and its Y components. And then we'll express it then in component form. So if I'm looking at T1, now I made this X and Y here, so this 50-degree, I'm going to move it down and put it down here as well. There's our parallel lines, and we got our angle, our transversal that cuts across them. And those alternate sides, they're called alternate interiors, are congruent or the same size. So there's our 50-degree. So if I wanted to use some trig then to express X, and I'm going to express it in terms of this side here, which was T1 magnitude, then I could write that down as cosine of 50 is going to be adjacent over hypotenuse. And so the X component would be the magnitude of T1 times the cosine of 50, except I'm in quadrant 2, so I'm going to need to put a negative on that. So it's going to be negative magnitude of T1 cosine of 50 degrees. And then the Y component will be similar setup, except it's going to use sine because we want to do opposite. So that's going to be Y over the magnitude of T1. And then we'll put the magnitude of T1 over here. And so our Y component is magnitude of T1 sine of 50. Okay, now let's do the same thing for the second tension vector. And so looking at this one, I have 32. So it's going to be the very same type setup. In the interest of room on the slide, I'm not going to write it down, but I would do adjacent over hypotenuse, but I would use 32 and solve it for X. And I'm going to have the magnitude of T2 cosine 32. And that one's positive because we're over here in quadrant 1. And then the y value is going to be magnitude of T2 sine of 32. Okay, so that's component form of the vectors. It breaks it down into their x component and their y component. Now let's do another vector for the engine. So we'll call that E for engine. Okay, and there's my vector. So it's nothing in the x direction, and it's negative 100 in the y direction. So the sum of all the vectors equals 0, or we could put it so that we know that if we had T1 plus T2, that's going to end up equaling our engine vector. So let's do that, and let's set them up looking at x components to get the first equation and y components to get the next equation. So let's do the first components. So that means that negative magnitude of T1 cosine 50 plus magnitude of T2. I'm just adding the first components of both of those tension vectors, and it needs to equal the first component of the engine vector. So I just took this one plus this one has to equal this one. And now let's go ahead and do the same thing for the second component. So I've got magnitude of T1 sine of 50 plus magnitude of T2 sine of 32, and that needs to equal 100. It's not negative 100 because the sum of all of them equals 0, but then I moved this to the other side, so that changed the sign. All right, what I'm supposed to find in this problem is the tension on both of those wires, which is the magnitude of T1 and the magnitude of T2. And I've got two variables, but I have two equations and two variables. So I can solve these by substitution or elimination. We can kind of decide what we want to do there. And I think what I'm going to do, because the first one is equal to 0, I'll move this term over to the other side, and then I will solve it for T2. So let me put that in another color down here. So I've got magnitude of T2 would equal, I'm going to solve it for this right here. So I'm going to move this one to the other side. So that's magnitude of T1 cosine 50 divided by cosine 32. So I got this by itself, and it's got that equation that's in red. So now I can substitute that for T2 in the second equation. So I could take that and put that in there for T2 in the second equation. I'm kind of squished for space here, so that makes it a little bit crazy. But what I'm going to do to fit it all on the slide is, while I go ahead and substitute that in, I'm going to also in the same step solve for T1, because there will only be one variable. Well, I guess I'll have it in two places, and then I can move it over. I'm just trying to think how I can fit that. I may end up having to erase something here. Okay, I think I'm just going to erase all of this up above so that I have some room to work this. And so remember what we were doing. I wanted to substitute in for T2 in that second equation, and then the only variable I'll have is T1, and I can solve for it, but I just needed more room than I had there. All right, so I'm copying down this green equation here, but while I copy it down, when I hit T2, I'm going to substitute in over here. So, and I'm going to put it up above. So I've got magnitude of T1 sine 50 plus, right here I'm going to substitute in magnitude of T1, and I've got cosine 50 over cosine 32. And then there's a sine 32 there as well. And that needs to equal 100. All right, so let's solve this for T1. There's a T1 magnitude of T1 there and a magnitude of T1 there. So we're going to factor that out in front, magnitude of T1, and that will leave us sine 50 plus cosine 50. And I'm going to rewrite these guys as just tangent 32, and that equals 100. So that means the magnitude of T1 will equal, I'm going to divide by all that stuff, so it's going to be 100 divided by sine of 50, make a longer line there, plus cosine of 50, and tangent of 32. Now, looks like some weird stuff, but it's just punch buttons. So grab your calculator, make sure you're in degrees, do 100 divided by, and make sure you put all this in parentheses because that's all in the denominator, and we will have the magnitude of T1. And let's round it to the nearest tenth of a pound. So it looks like that's 85.6 pounds. So there is the tension on the first cable. Now to get the tension on the second cable, it was down here at the bottom. So if you've already got that value in your calculator, you can just use it, multiply it by the cosine of 50, and divide it by the cosine of 32, and that will get us T2. So T2 is going to be, looks like 64.9 pounds.